It is one of the best-selling bowriders in its class. It has a standard fuel capacity of 150 gallons, twin sterndrive or outboard power options, producing up to 600 horsepower combined, and a fit and finish level that Sea Ray has spent decades positioning at the premium end of the recreational market. It is also, by design, specification, and hull geometry, not an offshore boat. The question nobody asks out loud when they are walking the dock at a boat show is this: what actually happens if you take a Sea Ray 350 SLX into open ocean and push it past the conditions it was designed to handle? The answer involves hull design, seakeeping behavior, fuel range, and a documented gap between what this boat does exceptionally well and what it was never engineered to do. Let's get into it. The Sea Ray 350 SLX is a bowrider sport boat built on a fiberglass hull with a moderate V bottom. The transom deadrise on the 350 SLX runs at approximately 18 to 20 degrees depending on the model year. That figure sits between the shallow V hulls optimized for flat water performance and the deep V hulls built for offshore seakeeping. It is a compromise, and it is a deliberate one. Sea Ray designed the 350 SLX for the conditions its buyers actually use it in: protected bays, large inland lakes, intracoastal waterways, and coastal day trips in benign weather. For those conditions, the moderate V delivers exactly what is required. It is stable at rest, comfortable at cruise, and capable of absorbing the short period chop common in protected waters without transmitting excessive motion to the passengers. Length overall on the 350 SLX is 35 feet 5 inches. Beam is 8 feet 6 inches. Dry weight runs approximately 9,500 pounds without engines. Maximum capacity is rated at 12 persons. Standard fuel capacity is 150 gallons, with an optional extended tank configuration available on certain model years that brings total capacity to 200 gallons. The standard twin engine configuration uses twin Mercury or Volvo Penta sterndrive units in the 300 to 350 horsepower range per engine, producing 600 to 700 horsepower combined. Top speed with that installation and a light crew load reaches approximately 48 to 52 miles per hour, or 42 to 45 knots, depending on engine specification and load. Cruise speed for range planning purposes falls between 28 and 35 miles per hour at an economical throttle setting, approximately 24 to 30 knots. At that speed, twin sterndrive engines in this power range consume fuel at a combined rate of approximately 20 to 28 gallons per hour depending on load, sea state, and throttle position. At 150 gallons and 24 gallons per hour average consumption, the 350 SLX carries approximately 6.25 hours of cruise endurance before the tanks are dry. At 30 miles per hour cruise, that produces a dry tank range of approximately 187 miles. Apply the 1/3 reserve and the operational planning radius becomes 62 miles from departure. At 200 gallons with the extended tank, the dry tank range at the same consumption rate extends to 250 miles, and the 1/3 reserve planning radius becomes 83 miles. Those are the range numbers for protected water operation at moderate load. They are the numbers this hull is built to deliver, and within its intended operating environment, they are reliable. Now here's what happens when you take those same numbers offshore. Open ocean changes every variable in the range calculation simultaneously, and not one of them moves in a favorable direction. Sea state is the first variable. The 350 SLX's moderate V hull is tuned for the frequency and amplitude of protected water chop. Open ocean swell is a different mechanical problem entirely. A 3-foot ocean swell with an 8-second period loads the hull differently than a 2-foot bay chop with a 3-second period. The 350 SLX will handle moderate open water conditions. A 1 to 2 foot offshore swell in calm weather is well within the hull's operational capability. But as swell height climbs toward 3 to 4 feet and period shortens in an active sea state, the moderate V bottom begins to transmit motion to the deck and the passengers at a rate that forces the operator to reduce speed to maintain comfort and control. That speed reduction directly compresses the already limited range radius. If offshore conditions force a reduction from 30 miles per hour cruise to 20 miles per hour to manage passenger comfort and hull loading, fuel consumption does not drop proportionally. Engines in this power range do not deliver linear fuel savings as speed decreases under load. The result is more fuel consumed per mile at the reduced speed, a shorter practical range than the flat water calculation suggests, and an operator who's now further from shore than planned with less fuel than expected. That sequence, deteriorating conditions, forced speed reduction, increased fuel consumption per mile, compressed range, is the documented pattern in recreational boat incidents involving vessels operated outside their intended sea state envelope. The 350 SLX is not uniquely vulnerable to this pattern. It is a textbook example of it because its performance specifications were developed in the conditions it was designed for, not the conditions that test its limits. The sterndrive configuration introduces a second offshore vulnerability. Sterndrive units, the Mercruiser Bravo or Volvo Penta equivalent installations, common on the 3.5 SLX, position the drive unit at the transom with the lower unit submerged and the gimbal housing integrated into the transom. In beam seas or following seas with significant wave height, the drive unit is exposed to wave action in a way that a conventional inboard shaft drive or pure outboard installation is not. A sterndrive unit struck by a breaking wave or loaded heavily in a following sea can sustain damage to the bellows seals, the gimbal bearing, and the drive shaft. Those are not catastrophic failure modes in most circumstances, but they are maintenance events that become progressively more likely as sea state increases beyond the hull's designed operating range. The honest assessment of what happens when you take a Sea Ray 350 SLX into open ocean is this. In benign offshore conditions, light swell, calm wind, within 60 miles of a safe harbor, the 350 SLX performs competently. It reaches its cruise speed, delivers its documented range on a 1/3 reserve basis, and provides the comfort level its passengers expect. Those are real capabilities and they are not trivial. A 60-mile operational radius covers a substantial portion of coastal day trip itineraries, and the 350 SLX executes that mission with the fit, finish, and passenger capacity that built its market position. What it does not do is absorb offshore conditions beyond that envelope without cost. Speed drops, fuel efficiency degrades. The sterndrive becomes a mechanical liability in sustained heavy water. The range radius that looked adequate at the dock contracts in real conditions to a figure that demands conservative planning. And the moderate V hull, which is the right engineering answer for protected water operation, becomes the binding constraint offshore. Sea Ray built the 350 SLX to be one of the best recreational day boats at its length and price point. The documented evidence supports that assessment completely. What the evidence also supports is that open ocean operation beyond light conditions is not what this hull was engineered for, not what its performance figures were developed in, and not where its design decisions deliver their best results. Understanding that distinction before departure is the difference between a successful offshore day trip and a compressed range calculation in deteriorating conditions with a Coast Guard radio call at the end of it. If you enjoyed this video, please like, subscribe, and turn on the notification bell. More deep boating stories are coming.